All right, students. So in this class, we shall be focusing on vector resolution, okay, in 2D, or resolution of 2D what? Vectors. The word 2D means what? Two-dimensional. Are you there? Then you can also resolve vector in what? In 3D. Are you following somebody? Okay, but let's look at 2D vector what? Resolution. Now we have defined vector resolution, I repeat again, as the splitting of what? Of a single what? Vector, right? Into what? Two or more component vector, right? Such that when added together forms original what? Vector. Is that not? Now listen. By now we know what our vectors are and their examples. Is that not? We have acceleration, we have displacement, we have force, we have weight. Are you getting the gist here? If you are resolving vectors, it's not just only force we resolve. We can also resolve what? Acceleration. We can resolve velocity. We can resolve any quantity in form of what? Vectors can be resolved. Are you getting the concept? Now we have seen that the word 2D represents what? Two-dimensional, meaning both x and what? And y. When I say two-dimensional, I'm referring to what? X and y components. Once I say 3D, I'm referring to what? X, y, and what? And z. Are you getting the gist here? Well, put this down. If I have a vector, or given a vector f acting at an angle theta along the positive x-axis as shown below. Please pay attention. If I have a single vector here, f, okay, acting along what? At an angle theta, right? Along what? The positive what? X-axis. Meaning that the vector f is along this line, but this vector can be resolved into two components. Like we saw under projectile, that when the body is being projected, right, the body moves in a parabolic path. Then the pathway is given as this, right? When we have what here? Ux and what? And uy. Then we have the angle of what? Projection. What we call here? U, right? This is called the resultant what? Velocity. Are you getting the concept now? So if I have a vector of this kind, but here we have what we call here what? F. So this F can be resolved into how many components? Two components. Are you there? So the value of this F can be placed somewhere here, right? This is force F. We have our angle here, what? Theta. Along the what? Positive what? X-axis. I can resolve this F into what? Fy and what? Fx. Are you getting the concept? Now let's resolve. Resolving. Watch. Resolving the horizontal components Listen, please. Listen. If I'm resolving my fx is what? Horizontal what? Component of the force. Abi? Fy is what? Vertical what? Component of the force. If I'm resolving this, I will resolve fs with respect to what? F, right? You are aware. Fs is in what side? Adjacent side. What about f? Hypotenuse. What about fy? So that means to resolve f or fs, what do we use? From the Stoke-Artois principle, what do we use among these three? The word can, right? So from here, to resolve f of x, we say using what? Using cos what? Cos theta. And what's that cos theta? Adjacent over what? Hypotenuse. What's the adjacent here? Fx. What's the hypotenuse here? The f. So what do we do to find fx? We cos what? Multiply. Are you following somebody? Cos multiply. By the time we cos multiply, what do we have here? What will be the fx here? Will be what? F cos what? Cos theta. Let's call this equation what? 1. Now let's resolve. Resolving the what? The vertical what? Component of the force, Abi? Of the force. Now if I'm to resolve the vertical, what's the vertical force here? Fy. I will resolve this with respect to F, right? So Fy is what? Opposite. What's my F? Hypotenuse. So which side will I use here? I'll use sine, Abi. So I'm going to say using what? Sine what? Sine theta. And what sine theta? From the what? So, right? Opposite over what? Hypotenuse. What's the opposite here? Fy. What's the hypotenuse? F. So what do we do here to find Fy? The same concept, Abi. We cross what here? Multiply. And that will give us what? Let's go. Fy equals to what? F sine what? Theta. Equation what here? 2. Are you getting the concept? Now, let me ask this question. If I'm to find F, what do we do to find F? I'll apply Pythagoras what principle, right? That says what? F squared equals what? Fs squared plus what? Y squared. So that means that to find the magnitude, Abi, the what? Magnitude of what? Of the force, F. That will give us what here? Let's go. Force F squared, right? Equals to what here? F what? Okay, F x what? Squared plus what? Fy what here? Squared. And that will give us what? Let's go. Minus K. Where are you getting minus from? What do we do to find our F? We take root of both sides, Abi. That will give us what here? F equals to what? Square root of, I can just say Fx squared plus what? Fy what? Squared. And stop here. This is the magnitude. Yeah, magnitude of the force. No, you stop here. Yes, as the answer. Let me ask this. If I'm to find the direction, what will I do? In this case here, when you have a single vector you are resolving, and the angle is along the positive of x-axis, the direction is simply the angle given. Are you getting the concept here? So you don't need to keep to find what again. If I have a single force I'm resolving, and that force is implied at an angle theta to the positive what? X-axis, that angle theta becomes the direction of that force. Is that clear? We are coming to that aspect. We are coming there. You now use the direction angle I taught you. Okay, someone is asking this. What if is here, right? I will not say. Let's say, but then you must have gotten this. Hope you are aware. This was given, it's given. Let's say yes, 20. What will be the angle now? 180 minus what? 20. Is that clear? I'm coming to this part, so let's take it one after the other. There's a step I skipped. Let me just show you the step. Please listen. Listen, stop writing. I skipped a step. Let me explain. You know we have gotten our fx. Where's our fx? F cos theta. What's our what? Fy. F sin theta. Once you get to fs and fy, you have to get the vector notation. The what? Vector notation of the force. The vector notation of the force is, don't be scared. It's not just like saying sum of all the forces. Let me just say the force itself, which is what? This F. Are you there now? No, we resolve it in how many components? 2 components, which are what? X and what? And Y. And S represents what? I, B. Y represents what? J. Are you there now? What do we call I and J? They are called unit what? Vectors. I think in my class I've explained what are unit vectors, right? The word unit means what? 1. A unit vector are those vectors that has magnitude of what? Of 1. Like your I, J, K. What if I have I? What is the size of I? 1. If I have J, what is the size of J? 1. Just like that. Unit means 1. Now, I can represent this vector, F, using what we call vector what? Notation, which is equals to what? Fxi plus what? Fy what? J. Then from here, what is our F modulus here? What will it be? Square root of what? Fx all squared, B plus what? Fy all what? Squared. Can you remember? I don't know if you remember what we did a vector modulus. Yeah. Now, if I have vector A equals to, let's say, 2i plus what? 3j plus 6k. And we have to find the modulus of what? Of A. This sign means what? Magnitude of what? Of A, or the size of A, right? What do we say is the answer here? Square root of what? 2 squared plus what? 3 squared plus what? 6 squared. So if I have a force or a vector in vector notation just like this, to find the size of that force, what do we do? Square root of what? Fx squared plus what? Fy squared. You see the same thing I did here. But yeah, I just have to derive this from what? This diagram, right? Using what we call Pythagoras what? Theorem. Right there? So when you get to Fs and Fy, please present your answer first in this form before finding what? The modulus. Now when the angle theta is inclined along the vertical axis of the resultant vector, when the angle theta is inclined along the vertical axis of the resultant vector, as shown below. Listen. We have two cases here. The first case is when theta is where? Along what? The positive what? X-axis. Are you getting the concept? Along the horizontal. Are you there? We can also have the case where theta is where? Along the positive what? Y. Meaning I can have my theta here. No longer here again. Are you getting the concept here? Can I proceed? As shown what? Below. When theta, listen, when theta is along the x-axis, Fs is what? F cos theta. When theta is along the what? X-axis, what's Fy? F sin theta. But when theta is along the y-axis, Fs becomes F sin theta. When theta is along what? The y-axis, what's the Fy? F cos theta. Just the reverse. But let me prove it here so you can see. Now what? We are saying this, right? This is still our first, is that not? We're now looking at a case whereby we have, let me complete this. Let me just bring out the initial diagram. This is what, yeah? Fy, this is what? Fx, right? Are you following? Now, I'm not saying that if the angle is now somewhere here, you know what I'm saying? I can still generate what, yeah? A right angle what, yeah? Triangle. You understand the concept? Now, in this case here, this line here is Fs, Abi. This is also equals to what, yeah? Fx. This is what? Fy. This is also equals to what? Fy. Is that not? Now, it means that the angle facing the side facing the angle is now what? Is now what? Fx. Is that not? If the angle is there, what is side facing the angle? Fy. So once I remove this and we now place the angle along the positive, like your resultant is now making angle theta along the positive y-axis, the reverse becomes what the case. Now watch what will happen. Can we now resolve now? Can we resolve? Now let's resolve. Resolving what now? The what? Horizontal what? Component, right? Now, if I'm to resolve the horizontal components, it means I will resolve what? This Fs, Abi, with what? With F. Are you getting the concept? Are you following? I want to resolve my Fs. The angle is here. I can even put this angle here because they are alternate. If I put this angle here, Fs is still facing the angle, Abi. So the alternate angle, right? But let me maintain this, right, to avoid confusion, right? So this side is facing the angle, Fs. Then we see maintain what? Hypotenuse, Abi. This becomes what? The adjacent. Is that not? Now let's resolve. Resolving Fx. I will resolve Fs with respect to F. Fs is in what? Opposite. Abi? What's that F here? Hypotenuse. So from the SOHCAHTOA principle, which of these am I going to use? I have opposite and I have hypotenuse. I have opposite, I have what? Hypotenuse. I will use what? Using what? Sin what? Theta equals to what? Fx over what, yeah? F. Can I cross multiply this? That implies what, yeah? Fx equals to what? F sin what? Theta. So if we are to resolve now, resolving what? The what? The vertical component, right? Who can tell me what will it do? I'm resolving Fy with respect to F, Abi. Fy is in what part? Adjacent. And what again? Which one will I use? Pass. Good. I want to say what, yeah? Using what? Are we saying sign again? Using cos theta equals to what? Adjacent is what? Fy over what, yeah? F. So that means cos what, yeah? Cos theta will give us what, yeah? Sorry, I'll cross multiply, right? That will give us what? Fy equals to F cos what? Theta. F cos theta. Then what do we say we do again? Vector what here? Vector notation. Please, this is how it should come. My vector notation of my force. What's the vector notation here? F what? Plus what? J. So what's our force resultant? Square root, Abi? Of what, yeah? Square plus what? Fy all squared. This is the magnitude, Abi? Magnitude of what? Of the force. Are you there? Where's that direction? It's still here, right? The angle theta. Exactly. Okay. Let's solve a problem under this first. We'll now continue. This is just for a single force resolving. We can have more than one forces. Let's solve a problem here. Are you ready? The resultant of two forces. From your textbook now. The resultant of two forces. The resultant of two forces at right angle to each other is 100 Newton. Like me, The resultant of two forces at right angle. At what? Right angle to each other is 100 Newton. To each other is 100 Newton. If one of the forces makes an angle of 30 degrees, if one of the forces makes an angle of 30 degrees with the resultant, compute that force. Compute or find the force. Compute means find what? The force. Now let's look at this. This is one of the most simplest questions. What do you do first? Generate your what? Your right angle what? Triangle. Are you getting the concept? Now listen. We are told that read the question for me. Is what? We are only giving here to be what? 100. This is the resultant. Open your way. Of two forces. What are the forces here? Fx, Abi? And what? Somebody? Fy. And Fy. Fx and what? Fy. The force there is what? 100. Let's indicate our direction. By now you know why we are doing it, right? Okay. Now we are told that what? Was the angle given to us? What's the angle there? The angle is what? 30 degrees. So the what? Resultant, Abi? Then we have to find what? Which force is that? Is it Fs or Fy? You know I say something. Why? You know I cannot put it here. The first case I gave us is what? When the angle theta is where? Along the positive what? S-axis, right? We are looking at the directional angle now. Where is it fine? Where is it? Is here. It cannot be here now. You know what I'm saying? I can't have my directional angle here. Because they are starting from here. You understand what I'm saying? No vector start from here. No vector start from the head and come down to the tail. But from the tail to what? To the head. Do you get the concept? So that means I'm looking for Fs. How do we resolve Fs? Record. By now you should know, Abi, that Fs is what? Somebody. F what? So what do you have? What do I have here? Cos what? What do you have here? What's cos 30? 11 here. What's cos 30? 0. What? 8660. Multiply this. What do you have? 80 what? 6 point what? 6 Newton. Oh yeah, put this on. Because we are told that one of the forces makes what? An angle 30 degrees with the horizontal, which is Fs. Now say find that force. That is our Fs. Can you ask me why is it Fs equals F plus theta? I don't think you want to resolve this now. That was the first case we looked at. You have forgotten? Wow. Let me repeat. We see if we have this here. Let's say we have a force here, right? And we have here to be what? Fx, right? We have an angle theta. Can you remember that? We say resolving, right? Resolving horizontal. We resolve Fx to be what? F cos what? Theta. The same diagram is given here. Do you understand? Okay. Example 2, put this on. Find the component of each vector. A, force of 300 Newton at 30 degrees Force of 300 Newton at 30 degree above the x-axis. B. Force of 220 Newton. 220, that 220, sorry, 200 Newton. Force of 200 Newton at 210 degree. Force of 200 what? Newton at what? 210 degree below the x-axis. We have to find the component, Abi, of what? What the first one? The force is what? 300 Newton. At what? 30 degree above what? The x-axis. The B part says what again? Component, Abi. The force of what? 200 Newton at what? 210 below, Abi. Below the what? X-axis. Now pay attention. Solution. These are just simple question, but it's kind of technical relating. Now, force of our force is given as what 300 Newton, which is our resultant what force, Abi. At what angle there? What is the reference? X-axis. Above the x-axis. Meaning, for the first one, if I have this, where is the x-axis? This, Abi. It means I'll go above. Above means I'm coming here. Here's what? 30 degree. Are you getting the concept? When I say below, below is what? Under. When I get to this side, let's finish this first. So what do you have? If you don't understand, ask now. Not after something, not tell me I don't understand. When I say above, it means I'm going above, Abi. What angle is there? Somebody help me. 30. When I put it there, you're your own. So what do you have? What is the force there? 300 Newton. So I can complete my what? Triangle, right? Okay. So what do we call here? Fx. What do we call here? Fy. What are we asked to find? Components. Components, Abi, of this equation, of this vector. Of the vector F equals to what? 300 Newton. Simply means I will resolve what? Horizontally and what? Vertically. Are you getting the concept now? So let's resolve. Resolving the what? Horizontal force, right? Horizontal force. Which is what, yeah? Fx. If I'm resolving my Fs, I will resolve it with respect to what? F, Abi? My F here is what, yeah? 300 Newton. So let's go. What will it be? I've said that if the angle is along the what? S-axis, resolving Fs, I'll use what? Cosine, Abi? So what will it be? Fx equals to what? F cos what? Cos what? Theta. That will give us what, yeah? Fx equals to what? 300 cos what? Cos 30. Let's go. So that will give us what? Our Fs equals to what, yeah? What is cos 30? So 300 times 0.8660. What do you have as Fx, yeah? So 259 point what? 8 Newton. So what do we do here? Here becomes 8 Newton, or I can just say my Fx is what, yeah? 259.8 I what? Newton. Hope you know why we are putting I there. Why? Because I'm resolving the S, Abi. So that is my S component, the Fs component. Now let's resolve now. Resolving what? Or let me say Newton, then put the I here. Resolving the what? The vertical what? Component. By now you should know what to do, Abi. That means what? I'm looking for what? Fy. What's my Fy? F sine what, yeah? Sine theta. That will give us what we have here. 300. Sine. That will give us 300. That will give us what? 150 Newton I, right? When I say component, what does that imply? Vector notation. Vector what? Notation. So the components here represent the vector notation. The components of what? Of F. What do we say it is again? F equals to what? Fxi plus what? Fyj. So what do you have here? What's my Fx? 25. Where? Sorry, J. The Y component is J. Thank you. So what's my Fs? 259 point what? 8i, right? Okay, let me just make it not now. Now squares if you are finding resultants. I'm coming. What do you have here? F is what? What's my FS? 25 what? 9 point what? 8 Abby? 8i plus what? What's my FY? 150 what? J. This is what I'm looking for. Hope you're aware. Let's say find the component. If they not say find the magnitude, what would I do? You now square it. Now apply the Pythagoras what? Principle. Do you understand? Component is not magnitude. Component means bring out the vector in what? S and what? And Y. Are you getting the concept here? If I'm to find, who can tell me now, what is the magnitude of this force? If you look for the square root of this plus square root of this, Abi, when you add everything, find the total square root, you will see 4 back to 300. Now let's solve the B part. Okay, for the B part, if we have this, we are told that the force is 200, right? But the angle is what? Below what? Below what? Meaning I will start from here. I've covered what? 90. I've covered what, yeah? 180. Are you there? What am I looking for? If I should come here, I've covered 270. That means 210 is somewhere here, Abi. Eh? Eh? Why did I start from down? Let me explain again. Below the S-axis. This is my S-axis, right? Below means I'm coming below. Above means I'm going up. Eh? Can we now go below now? Why going below? What do you have here? We cover 90, Abi. Our aim is to bring out what? 210. So when you go, we have 90, 180. Somewhere here I can generate what here? 210, Abi. Now what? That means here we have 210. From here to here is what? 270, Abi. 270 minus what? 270 minus 210 is what? Is what? 60. So what be here? What be here is 60. Right? Is that not? From here to here is what? 270. Right? Minus what? 210. Is it not? Here is 270, Abi. I'm now subtracting what from 270? 210. What will remain? Here is 60 now. That means there is what? 30 degrees. Because 30 plus 60 is what? 90. Are you getting the concept now? So that means here we have what? What's my force here? 200 meters. What be here? What be here? Okay. Yes. 30 degrees below the S. Thank you. 30 degrees below the S as I'll just come here and generate what here? 30 degrees. Then complete what? My triangle. Is that clear? Eh? Is that okay? Yes. No. You know, that means the angle now you're not using is what? What's the angle I'm using now? This angle 30 here. But I'll show us how to use it. Yes. That 110 degrees is to get the exact angle needed to resolve this what? Force. We're not told that this force 200 Newton at what? 210 below the S axis, right? We have gotten it right. We're not found that the angle here is what? Is 30. Here is what? 210. Are you getting the concept now? So that means the angle I'm going to use is what? Is 30. No longer what? My 210. Huh? You said? No, now you are the one confusing yourself. Listen. Oh, are you confused? You're not confused. Okay, sorry for. Listen now. Listen. The major thing is to know the angle, the resultant, Abi, is making with what? X and what? And Y. Are you getting the concept here? Look at this. We are told that. Listen now. That this resultant force at what? 210 Abi degree below what? Yeah? The S. We agree that 210 can be captured where? Yeah, Abi. This is my resultant now. That resultant is what here? Is what? 200. I agree with you that this angle is what? Equal 210, Abi? Uh-huh. But here is what? My F what? So these are F, not R, right? This what? This is horizontal, right? What do you have here? Fs. What do you have here? Fy. How do you think? It's a reasoner. How do you think I will use this angle to solve? The angle between this x and this resultant is what here? It's 30 degrees. Am I communicating? I don't know. I don't know that way. There's no other way to explain this. Below is so no. This below means get the exact angle that we use to solve for what? For this force. You know what I'm saying? Now the challenge, if you don't consult your diagram, you might be tempted to use what? 210. You will just neglect this statement here, thinking maybe it's a typo error. You're on your own. What you need to do is bring out that angle here. We have seen that from here to here is what? It's 210. Then 270 minus 210 will give us what? Which is what? 60, Abi. What will be here? 30. So the exact angle that we use is what? Is 30 degrees. Listen, above the x-axis, the same statement. You mean I'll start from here. I'll come here, Abi. Is it not? And stop here. Then I'll find this angle here. Do you understand? It's not. Now let me tell you the implication here is that for this above the x-axis, it's simply saying that your resultant is first the world quadrant, third quadrant. For this, it shows what? It first the world quadrant, second quadrant. Not all the time that your resultant will fall here. It's very cheap. Don't see this all the time. Before we start, I gave you 4 diagrams, Abi. I said we have this, right? What happened here? Who can remind me? Alpha equals to what here? Theta. What happened here if I have this? What happened here again? This is my alpha, right? What do you call this? 180 minus what? Alpha. If I have this, what happened here? Where's my alpha again? This is my alpha, right? What's my theta from here to here, right? What do you have here? 180 plus alpha. If the value of our force is in the fourth quadrant, what do you call here? Alpha. Where's my theta again? Let's go. 360 minus alpha. All this while, we have been solving when it falls in what quadrant? First quadrant. Eh? She asks. I've already okay now. She's not saying that if the angle, right, is what 210 above one lequire. I've done it before. Hey. Now listen. Watch. You will not answer me now. Above means I'm starting from here. What is the angle there? 210. I cover 90, Abi. Cover 90, right? It's somewhere here, right? What do you call here? 60. What do you call here? 30. Now it shows that the value of my what? Of my force falls in what quadrant? Look at it in the what? Third quadrant. What you need to do now is to pay attention how to resolve your fault in other quadrants. Is that not? You have to pay attention and learn. That's why you are here. Listen. Can we repeat this again? Now we know better, right? That this angle is from where? Yeah, right? Good. Here we have what angle here? 30 degrees. I can remove this now. I don't need it. Are you following? Okay. What do you call it? What's our F here? 2 what? 100 Newton. Here we have what here? Fx. Here we have what here? Fy. Now pay attention. Now pay attention. Listen. I will use 2 methods to solve this. Then you can choose anyone you want. I will use the concept of directional angle and the concept of normal vector what? Resolution. Now watch. Listen. Solution to this. Whenever we have a Cartesian diagram, here we have what here? Plus y, Abi. Here's what? Minus y. Hope you are aware. What side is here? Minus x. What side is here? Plus what? X. It means that whenever your force falls in on this side, is what? Positive. Whenever your force falls in here, is what? Negative. When your force falls in here, becomes what? Negative. When it's not, it becomes what? Negative. Positive. Are you getting the concept? Now look at it here. Where is this Cartesian diagram here? Where is here? Eh? Where's our force? Is here, but this is my force, right? This force is somewhere here. What do you notice? If I'm resolving my horizontal component, it becomes what? Negative. Is it true? Because it's here. I mean, if I'm resolving my what? Vertical, it becomes what? Positive. Are you getting the concept? Now, but don't forget that whenever the angle theta is on the horizontal component, what's your Fs again? F cos what? Theta. I gave this now. Hope you can remember. Don't forget. So this is very important. If this angle is here and I have what here? Fx. And here's what? Fy. Let's say I have F. Abi? What do we say is our Fx again? F cos theta. What's our Fy? F sine theta. But if I have a diagram like this, let's say the force, the angle is now here, right? Yeah, I still maintain what here? Sorry for this diagram. Here is Fs, Abi. The angle is along what axis? This is my Fy, right? Okay, here we are saying that Fs is what? F sine theta. What's my Fy here? Are you getting the concept? We discussed this morning. This is the basic you must have to learn. Before you resolve, find out where is the angle located. Is it on the X or on the Y? On the X, I'll be along what? The X axis. That means if I'm resolving my X components, it becomes what? F cos what? Theta. But Y becomes what? F sine theta. But if I'm resolving my X components, it means my Fs is along what axis? Negative. It becomes minus F cos what? Theta. Fy is positive. You know why it's positive? This force here, right, is found where? Here, right? It's found here now, which is this. So while resolving it, horizontal and what? Vertical, right? Horizontal is what? Negative. What's vertical? Positive. But also because the angle is where? On the S-axis. Fs is what? F cos theta. What's Fy? F sine theta. Can I do that now? Now watch. Let's resolve. Resolving. The what? Horizontal what? Component, Abi? That is what, yeah? Fx. What do you say it is again? Minus, right? F cos what? Theta. Hope you know why it's minus now. It's not a new thing, right? It's where? Along the what? Negative axis. Let's go. What do you say is our F here? Tell me now. 200, Abi? Minus, Abi? Cos what, yeah? Cos 30. Thank you. Cos 30. And that will give us what? Let's go. What is cos 30? Minus 200 times 0. What? 8660. And what do you have here? Let's go. Check. Minus 173.2. Only, right? And S complex represent I, Abi. I'll just put what? Let me just put mine. That'll be what? N what? NI. Thank you. Oh yeah, watch. Let's go. Watch. What do you think will be our Fy? Fy is what? Hope you know why it's now plus, Abi. Why is it plus? Because that force is where? On the positive what? Y, Abi. So let's go now. What do you have here? What's my F? 200 sine 30. Let's go. Fy is what? 200 times. What's sine 30? 0.5. So what's our Fy here? 100 Newton what? J. Are you there? Okay, what are we have to find? The component, right? Therefore, or recall that F will give us what? Let's go. Fsi plus what? Fyj. Abi? So what will it be? Let's go. What's my Fs? What's my Fs? Minus what? 173 point what? 2I plus what's my Fy? 100 what? J. You can just put this all in what? Somebody? Newton. Final what? Yeah? Answer. Yeah, thank you. Alright, let's look at this question. Look at this. We are given the diagram. We are given two forces here, acting at a point. Here we have our force Abi, F1. Is that not? We have what here? Our force F2. and we have to find the resultant. Are you there? Now, what we do is to bring out the parameters, right? What are the parameters we have here? Yeah, let's go. What's that theta 1, yeah? 25, right? Degree. What's that F1? 7 point what? 4 Newton. What's theta 2, yeah? Huh? What's theta 2? 70 degree. What's F2? 1 point what? 2 Newton. Now, what do we do? Look at me. Sum of what? We have to find the sum of what? Horizontal what? Horizontal forces. Now, let's resolve. Meaning sum of all forces in the x-axis is equals to what? F1, force 1 is in what quadrant? In the first quadrant, right? Both x and y are what? Positive. So here becomes what? F1 cos what? Cos theta 1. Hope you know why we're using cos here. Because the angle is where? On the x-axis. Good. Now let's go. Now the other force here is where? Is on the negative side, Abi. If I'm resolving this F2 here, it becomes what? Minus. What do you have here? Minus what? F2 cos what? Theta 2. So sum of all forces becomes, what's the F1? They give me 7.4 cos what? What's theta there? 25 minus, what's my F2? 1.2, cos what? 70. What's cos 25? Multiply with 7.4, what do you have? 6.706666, right? Cos 25 times this, we give us this, right? Minus, what do you have here? What's cos 70? Then multiply with what? 1.2, what do you have? Everything. 0.4104. Can we subtract now? What do you have? 6.2962 what? I what? Newton, right? Okay, so what's the next now? Sum of all, sum of what? Vertical what? Forces. Meaning sum of what? F what? Y equals, now let's start again. For the vertical, my Y is what? Positive for F1. That means 7.4. F1 sine what? Theta 1, Abi. Why is this sine? Because the angle is where? Along the what? X-axis. So what do you have here? Let's go. F1 sine what? Theta 1. Are you there? Plus. Why we using plus here? Because for F2, if I'm to solve for F2, I'm resolving along what axis? Positive what? Y. Thank you. Plus what? Yeah? F2 sine what? Theta 2. Let's go. What's the F1 here? Let's go. Sine 25. Good. Plus what? What's F2? 1.2 sine what? 70. So let's finish up this. Sum of all vertical forces. Can we add up? What do you have here? 3.1272. Are you sure? Plus what? Yeah? 76. When you add up these two forces, what do you have? 4.25448. J what? Newton. Now the next is what? You can tell me. The vector what? Notation. Now let's find our vector notation of the resultant force, right? What will it be? Sum. Sorry, F, right? We give us what? Sum of what? Fxi plus what? Sum of what? Fy what? J. So our F becomes what? What do you have here at the sum of Fx? 6.2962I plus what do you have for Fy? 4 point what? 2548 what? J. All in what? Somebody? Newton. Now what do we do to find the resultant? What is the resultant? or the magnitude, Abi. What is the magnitude of this? What do we do? F, right, equals to what? Square root of what? Square root of this, right? 6 point what? 2962 all what? Squared plus 4.2548 all what? All squared. So F becomes what, yeah? Root what? 39.6421. When you square this, right, that gives us this. Now let's square this. What do you have? 18.1033. Okay. Now I calculate this now. So what do you have as F? Square root of what? 0.7454. What is the final answer here? 7.990. So I can say this is same as what? 7 point what, yeah? 6 what? Newton, right? Now, what the next now is to find what now? The direction. What would I use to find direction? My first what? Components. Are you there? This first component shows what? That the force F is located where? In the fourth quadrant. Why? Because both X and what? Y are what? Positive. Are you getting the concept here? So that means that if I'm to draw this, watch, my force is here, right? Okay, let's check this out. Okay, I hope you are following. Okay, what angle is here? You can tell me. Alpha equals to what here? Theta. You are aware? The reference angle equals to what? Directional what? Angle, right? Okay. All right. So what do you call here? Our F. And what do you have as the F here? 7 point what? 599 what? 0, right? What's our Fy? This for Fy, right? Okay, let's finish up. What's our Fy? 4.2548. What's our Fx? Are you there? Since the value of F falls in the first quadrant, that says that all is what? Positive. It means I can either use sine, cos, or tan, Abi, to solve. What do you use? Have you tried cos? As you use sine. As you tan, Abi? Using what? Tan what? Tan theta. Tan alpha equals to what? The word tan is from the word what? Which is what? Opposite over what? What's my opposite here? 4.2548 over what? 6 point what? 2962. So tan what? Tan alpha equals to what? 6758. So what do we have as alpha here? Tan inverse of what? 0.6758 what? 8. Abi? What do you have here? 34 point what? 05. Right? But since the same answer. But since alpha equals to what? Theta, right? That implies that your theta is equals to what? 34 point what? 05 what? 5 degree. Put it down. If you sign the same answer, use cos the same answer. You didn't do it well then because it falls in the first quadrant. You must have the same answer. Huh? Okay, this one. Let me summarize the concept of the directional angle. Most of you are still having issue with that. We already say that if I have force is equals to what? Fx plus what? Fy. Fxi plus Fyj. Are you there? This force F, we fall in what quadrant? In the first quadrant. Abi? Are you following somebody? In this quadrant, we are saying that alpha equals to what? Yeah? Theta. Theta is called the what? Directional angle. Okay, and it's measured from where? Positive what? X-axis. Down to where? This resultant line. Are you aware, somebody? Here we have what here? Fx and what here? Fy. Now, if I have this, F equals minus Fxi plus what? Fyj. Are you there? Now, what will it be? Yeah, the S component is what? Negative. Abi? Y is what here? Positive. So that means it will fall in what quadrant? In this quadrant here. Are you getting the concept? Let me make it sleepy a little. This, are you there? Now, this is my F, right? This is what? Fx. This is what? Fy. What do you call this? The reference angle, which is what? Alpha. Then directional angle is measured from where? Positive what? X-axis. Which is from here to where? To here, B. And we call it what? Theta. Theta is what here? 180 minus what? Alpha. Please take note. Then the other one, if we are saying that F, your force falls in both negative what? Fx and what? And negative what? Fyj. What do you think here? In the third world quadrant, Abi? Is that not? Are you following? Oh, sorry, third quadrant. Let me adjust this a little. Let me adjust it here. So it falls in here, right? Good. That means you are following. So what do you call here? Fx. What do you call here? Fy. What do you think will be the alpha? What will be the reference angle? On the S, Abi? This side. What about the directional angle? From here to here, right? Are you getting the concept? And it's called what? Theta. Theta here is what? 180 plus what? Alpha. Why is it plus alpha? Because I'm adding 90 plus 90 plus what? Alpha. Yeah. Why is it minus alpha? Because angle in the straight line is what? 180. We only subtracted what? Alpha from where? From 180. And that gave us the what? Directional what? Angle. Are you getting the concept? Yeah? No, which one? This one. The reference angle is here. Angle on the straight line is what? 180. So if I should remove this side, what's remaining is here? Here becomes 180 minus alpha. Minus alpha. Do you understand? So that when you add up this angle with this, I will have 180. It's like saying, for instance, let's say I have total length to be what? 10. If here is 2, what will be remaining here? How do you get the 8? 10 minus 2. Right? So if everything here is what? 180. And here is what? Alpha. What will be here? 180 minus alpha. That's the same concept. Are you getting the concept? Okay, for the third one, this second one, this one, no. Because if you look at your rotation from the positive x-axis, I'm covering what? 90 plus what again? 90 plus what again? The angle alpha. So 180 plus alpha. Do you understand the concept? I can only say, I can't even say 270. Let me not even say that, okay? That's academic what? Suicide. Number 4 now. If we have now that the force is what? Minus what? Minus Fx, right? Sorry. If we now have that, the force is what? Fsi minus what? Fyj. This falls in what quadrant now? In the fourth quadrant, Abi. What do you think will be the reference angle? This side, Abi. Alpha is there. Where's that directional angle? From here to here, Abi. Angle at the point is what? 360. So what will be here for theta? 360 minus what? Alpha. 360 minus that reference angle give us what? Directional what? Angle for this quadrant. In other words, reference angle is used to, it enables us to be able to draw what? The right angle what? Triangle. To know the exact right angle triangle that will be needed to find the what? Directional what? Angle. Hope you are aware that if my alpha is here, I can't find my what? Angle. Hope you are aware. It's not possible. I can't even put alpha here. Are you getting the concept? So alpha is here. Alpha, your reference angle is always on the x-axis, whether negative x or what? Positive x. But your theta is always measured from where? Positive x. Down to the resultant what? Line. Do you get the concept now? So this is the summary of how to find what direction of a single what force or more than what one forces.